Good morning, everybody. It's great to be here in Kern County. I can't imagine another location in the state of California that would draw this large and interested crowd in energy these days. It's a fabulous event here. Thank you, Richard, and the sponsors for inviting us to speak today. Again, my name is Curt Hildebrand, Senior Vice President with Hydrostor. Lorelei did a great job outlining the rapid development of renewables here in Kern County. We all know the state of California is on a trajectory to try to approach 100% renewables someday. That's a whole nother topic, but nonetheless, we are advancing, adding more renewables on the grid every day. We all know that renewables have certain pluses and minuses. One of the major challenges with wind and solar, as more capacity is added to the grid, is that these are intermittent resources. We all know when the sun's shining and the wind's blowing, that's great for renewables, but that's only about 25 to 50% of the year that those plants actually generate electricity. So what do we do in the hours of the year that the wind's not blowing and the sun's not shining? Well, as we advance more generation into intermittent generation into the grid, we need storage. The state of California, the Public Utilities Commission just ordered a procurement of over 11 gigawatts of new capacity for storage for the state of California. That's about a $25 to $30 billion investment over the next 6 years in California in energy storage alone. My company, Hydrostor, we're very proud to be here in Kern County developing what is the largest long-duration battery, if you will, not only in California, but in the United States. This project, our Willow Rock Energy Storage Center, I'll talk about a little more in detail, but it will supply the equivalent of about 400,000 customers for 8 hours when the wind's not blowing and the sun's not shining. So with that introduction, I'd like to talk a little bit more about our Willow Rock Energy Storage Center. Brief introduction on Hydrostor. This is the overall agenda. I'll go through quickly today. Introduction of our company and then get into more detail on our Willow Rock Energy Storage Center. Hydrostor was founded in 2010. We're headquartered in Toronto, Canada. We have 2 facilities in operation today, much smaller. Richard was kind enough to mention our investment from Goldman Sachs earlier this year. That is the largest global investment in a long-duration energy storage company globally to date. When I say long duration, most folks are familiar with batteries, utility-scale batteries. There's about 4,400 megawatts of large utility-scale batteries on the grid today. Those are great. They're typically 2 to 4 hours in duration, then they're dead. We actually store energy for 8 hours, so that makes us a long-duration resource. And we have 900 megawatts of projects being developed here in California. We'll look at a 4-minute video here shortly to describe our technology. We've been working on this and patenting various aspects of the technology. It sounds complicated. It's really pretty simple. We use air, water, and rock to store our energy in the form of compressed air. We've patented a number of technologies associated with storing our waste heat and thereby eliminating the need to burn natural gas. So we are a fully emissions-free technology. If we want to run the video, again, it'll describe our technology in more detail.
Hydrostor, Advanced Compressed Air Energy Storage, is a cost-effective, emission-free storage solution that can be sited where needed, delivering hundreds of megawatts and 4 to 24 hours of long-duration bulk energy storage. The system consists of 3 main components. First, the plant, which includes a compressor and turbine generator, thermal management system, and balance of plant equipment. Second, a closed-loop water reservoir, providing hydrostatic compensation to maintain the system at a near constant pressure during operation. Lastly, The system utilizes subsurface infrastructure, which is constructed using proven industry-standard mining techniques, including a blind bore shaft and purpose-built air caverns. Here's how it works. The system uses off-peak or surplus energy from the grid or a renewable source to run the compressor, which produces heated compressed air. Heat generated during compression is extracted from the airstream and captured by the thermal management system for later reuse. This adiabatic process, which uses sensible heat storage, increases overall efficiency and eliminates the need for fossil fuels during operation. Once the heat is extracted, the compressed air is sent underground and stored in purpose-built caverns where it is hydrostatically compensated, displacing water up the shaft and into the closed-loop reservoir. The system is now fully charged, capable of delivering power on demand over a standby period ranging from hours to days. When power is required, hydrostatic pressure forces the compressed air to the surface. It is reheated by the thermal management system, reusing the heat from compression and expanded through the turbine to generate electricity on demand. No fuels are used in the process, resulting in zero emissions. This method of charging and discharging significantly reduces water and land requirements, removing siting constraints and resulting in minimal environmental impact. Hydrostor Advanced Case is as reliable as pumped hydropower, but without the geographic or siting constraints. The key benefits of Hydrostor Advanced Compressed Air Energy Storage are bulk-scale long-duration energy storage, delivering hundreds of megawatts and 4 to 24 hours of duration. Low installed cost per kilowatt-hour with no fuel costs. No hazardous chemicals or use of fossil fuels. A proprietary built air accumulator allows for flexible project siting. System life up to 50 years with effective unlimited cycling. Built entirely from bankable equipment from Tier 1 OEM suppliers with decades of proven operation, providing low development risk through performance guarantees and bonding availability. Charge, discharge, and storage capacity are set independently to optimize system design. Synchronous generation provides rotational inertia, supporting electrical grid stability and resiliency. The system also delivers voltage support, spinning reserve, black start, and frequency response. Adiabatic process reuses heat from compression, resulting in enhanced round-trip efficiency. Hydrostor's technology is uniquely suited to help address electricity system needs for dispatchable capacity, including fossil plant and mine repurposing, as well as renewable integration, transmission deferral, and behind-the-meter or remote applications for mines and large industrial operations. Hydrostor, Advanced Compressed Air Energy Storage.
Any questions? There will be no tests. Again, one point I want to emphasize, this is a new application of existing technology. Compressors, heat exchangers, turbo expanders. What we've done is really utilized existing equipment that's been in proven operation for decades. We're redeploying it in a unique new fashion. So as far as technological risk, there's a lot of storage, energy storage ideas out there. Some are great, some are a little crazy at the end of the day. We've really focused on trying to get to a commercial solution as quickly as possible, and that's why we're utilizing proven technology. Our project is located west of Rosamond on the northwest side of the Willow Springs Butte. For folks that are familiar with the area, the Willow Springs Raceway is actually on the opposite side of the same butte. Our transmission lines will interconnect into the Whirlwind Edison substation about 11 miles to our west. We have various alternate routes for that transmission line. I know that that's impossible to read. That's a schedule, but I did want to provide just a quick overview. Again, 500 megawatts by 8 hours. Again, the largest energy storage project in advanced development in the United States that we're aware of. We are pleased to report we have full deliverability into the grid, meaning we can inject our full 500 megawatts into the Cal ISO grid. We are currently permitting through the California Energy Commission and Kern County, and the commercial operation date that we're targeting currently is 2028. We do have about a 4.5-year construction cycle. It's a very significant project by any measure. That's another one really hard to see, but that's a configuration of the site. About half of it will be occupied by equipment, the turbo expanders, heat exchangers, and the other half will be our closed loop reservoir. Easier to see there, again, about half of the site will be reservoir. That will be covered to minimize evaporation. A couple of renderings that we expect the facility, again, we're going through the elaborate permitting process, so these are renderings of the current design. We do have site control. We expect a project life of 50 years. When compared to batteries, that's about 5 times longer. The big utility scale batteries typically have to be replaced about every 10 years. They also decline with output. We don't suffer those same issues. Water needs, we need about 500 acre-feet to charge our reservoir. And again, we don't consume water in this process. We actually have a closed loop system. We actually produce fresh water out of thin air. When we compress ambient air, we do extract the fresh water, and not a lot of projects that I'm aware of can say that with a straight face. We're out drilling right now to confirm the subsurface geology. We're pleased to report we are encountering our expected granite at 2,000-foot depth. The cavern depth is about 1 million cubic yards that we'll be constructing. And to put that in relative terms, that's a football field by a football field by a football field in total volume. And we will meet all applicable noise standards. And again, no natural gas, no emissions. The cost will be well in excess of $1 billion all in. It's a very significant construction project. Again, 4+ years of construction. Average workforce of over 250 people and peak workforce of about 700, at least 2 million man hours of work, 25 to 40 full-time equivalent positions. Fiscal benefits will be significant to the county. And as I mentioned, we're working with the California Energy Commission as the lead CEQA agency, as well as Kern County. The application that we filed last year was deemed data adequate in July. Again, we're advancing towards permits in about a year's time from now. And this is our flagship project. In closing, I just want to highlight that we're very excited to be here in Kern County advancing this project, and being our first real utility scale project. We do have a similar project advancing in Australia right now, but being in California, we're real excited to be in Kern County. Being our flagship project, we're going to do this right, and thank you for your time and attention.
I don't think you all need waking up after Lorelei here, but I'm glad to be here. I'm glad you're all fed. And as Richard said, yeah, my name is Matthiah Larkin, Managing Director of Development at Clearway Energy Group. Clearway is an independent power producer focused on renewable energy here across the country, but home in California. I wanted to share just to follow on, actually, Lorelei and I did not plan this, but I wanted to also talk a little bit about the history of renewable energy in Kern. According to ACP, Kern now has 6.5 gigawatts of renewable energy projects. Of those 18 gigawatts that Lorelei and her amazing team have permitted, 6.5 gigawatts of those have come online. That's 3 gigawatts of wind, 3.5 gigawatts of solar, and just a few hundred megawatts of storage. But as you can tell, that's growing, whether it's with Curt and team here or with other many companies here in the room. Clearway has been in this in this county for well over a decade. As Richard noted, we are owners of a portion of the Alta Wind project. And I think that we're all in this room because of the all of the above approach that Kern has taken to development and energy development here. And you can see by the energy in this room and by the number of people here that continues to ring true. And I think it's a remarkable thing. You know, my team and I, we work across the country in many different counties, and I think the certainty that is provided by the permitting approach, through the strategic partnerships with local organizations and the myriad stakeholders that any energy project has to go through, whether it's renewable or oil and gas, is a testament to the people here in this room and the many people, hardworking people in Kern County. And that's why we have been here, that's why we are here. And I think it portends a great future, I think, for Kern, and Kern is well positioned to be able to take advantage of new technologies like Curt just mentioned, and with its existing infrastructure, that comes economic development, jobs, that comes investment, that comes tax benefits. According to statistics in 2020, there were over 120,000 people across California that are employed by the renewable energy industry. Those are high-paying jobs. Those are jobs that are, pay more than 29% of the average median wage across California, whether those are construction jobs or permanent jobs. Those are good jobs. Those are jobs that are here in Kern County because of that all of the above approach, because of the partnership approach that the county takes, whether it's elected officials, stakeholders, landowners. Just as a snapshot, in 2020, Clearway paid more than $20 million of property taxes. We paid landowners millions of dollars. We created more than 700 construction jobs that year. We also take a sustainable approach to development, whether that's working with our communities and our neighbors, ensuring that their needs are heard through the permitting process, and or whether it's focused on Kern's other natural resources. We've dedicated more than $1 million for condor and golden eagle conservation, preserved habitat. This balanced approach and the approach that Kern County takes to energy development generally is critical to achieving the goals of everybody in this room, the goals that the state has, the goals that we have as a country. Everybody's familiar with SB 100. Richard mentioned it at the outset. Just to sort of put it a little bit in perspective, by 2045, we will need to achieve those goals, we'll need approximately 86 gigawatts of utility scale solar and 58 gigawatts of storage. Kern remains uniquely positioned to be able to facilitate that energy transition. It's got an enormous amount of experience. It's got a great track record. It is friendly to business. And it's going to require everybody in this room working together. It's going to require hundreds and hundreds of thousands of people hours across many different projects to achieve that. There's an enormous amount that's been done. I'll just go back to the other slide for a second here. Just in the last 10 years, right, Lorelei mentioned this, we went from a few hundred megawatts of solar and wind to many, many gigawatts in just over a decade. So when you look at that, and then you look at what it's going to take to get to the 2045 goals, that's a 3x increase in what we've been doing already. That's an 8x increase in the amount of storage that we have to develop. That's going to require a lot of thought. That's going to require a lot of collaboration. That's going to require investment and in time and money. And we're all here in this room because we think Kern is the place to continue to do that. And I think that the great thing about building infrastructure, and I think that Kern has felt this and has felt this with 100 plus years of oil and gas being here and decades of solar and wind, is that infrastructure investment begets infrastructure investment, especially in energy. And when you think about the next wave of investment in order to achieve the SB 100 goals. People are going to be thinking about combining technologies. They're going to be thinking about putting storage on existing plants. They're going to be thinking about adding hydrogen. You can see here this little graphic is just thinking about what the state's needs are from a storage perspective. Right now, as Curt mentioned, we have short duration storage, up to 4-hour storage, but long duration is planned. There's gigawatts of long duration storage in the queue, whether that's lithium ion based or like Hydrostor's project. And following shortly on the heels there is green hydrogen. And I think Kern, when you think about the needs of green hydrogen, you need energy to power it. Got a lot of renewable energy here. And you need a transportation to bring it to the place that you want to use it, whether that's pipeline infrastructure or bringing it directly to industry. And those are things that all happen here in Kern County. Just to think about just for a minute, that's on the right, that's a project that we recently commissioned in Hawaii, a co-located battery and storage project. And that's the direction. That's the direction that Kern is headed. And so those numbers that you see for 2022, where there's just a few hundred megawatts of storage, there's going to be gigawatts in just a few years. And there's going to be gigawatts of those in Kern County, and Kern can continue to be a leader in that regard because of its history, because of the certainty it gives to business, because of its collaborative approach to development, because of its all-of-above approach to energy. Just a quick note about Clearway Energy Group. We're a large renewable energy-focused IPP. We've got 5.5 gigawatts of wind, solar, and storage in construction and operation, 22 gigawatts in development. A lot of that is in California. There's over 8.5 gigawatts of that in California. California is our home state, and a lot of that is in Kern County also. Just a couple of project highlights here for our focus in California. Included here are the Alta Wind projects, the part of the 7-project complex that was built between 2010 and 2014 here in Kern County. We also have the Rosemont Central project that was completed in 2020, created those 700 jobs, a big part of creating those 700 jobs in 2020. And we have other projects on the heels of those that we look forward to working with Lorelei and team and building the county and working with neighbors and local stakeholders to continue to further this energy transition, to continue to be this all of the above energy partnership that Kern has facilitated, that Kern has created the business environment for. When I first came to Kern County in 2009, I think the largest project, Lorelei mentioned the largest project in the country was like 350 megawatts. I think the delta between the largest project and most projects was probably 300 megawatts. And 20 megawatts felt really big then, and now 20 megawatts feels really small. There's hundreds and hundreds of megawatts. Many projects that are well over 100 megawatts. And that's the direction we're going, and that has been facilitated by the hard work of the people in this room. We've got a strong history here in Kern County in renewable energy. There's a list of our projects. And yeah, we're just happy to be here, and we are happy to continue to be a partner to the people of Kern and the companies that work here. And we're excited about what the next phase of this energy transition is going to bring, and we're excited to continue to do that here in Kern County. Thank you.
The thing about these discussions today is how do these projects come to fruition in the age of NIMBYism, right? I mean, the state wants renewable energy, and yet Kern County makes it happen. Other counties, the process is much longer. And I always say, well, it's not about being a NIMBYs, it's actually about being a banana, right? Build absolutely nothing anywhere near anybody. It's bananas, but anyway, I wrote that down because I always miss that acronym, pronounce that acronym. So we do have a couple minutes for I think we have some microphones. Do we have any microphones in the room?
Good morning. My question's for Curt. I wondered if you could talk a little bit more about the process for permitting the injection of air, whether that's US EPA permitted injection, and then also the geologic, like desirable qualities for the technology that you guys are embarking on, and any constraints.
Thank you for the question. As far as air permitting, I've fortunately or unfortunately been through thousands of megawatts of combined cycle natural gas permitting in my days. Those are very challenging EPA permits. For our project in Rosamond, we do not burn natural gas. We have no emissions. We compress ambient air and we release ambient air. So there's no EPA or other federal level air PSD permits or anything like that. So that's a great enhancement for our project. As far as the geologic conditions, we are looking for low permeability, low porosity rock, bedrock at approximately 2,000 feet depth. And that is a fairly common occurrence across the globe. We expect that about roughly 50% of the average footprint of the Earth would be suitable for our projects. We did site next to the Willow Springs Butte, given its volcanic origins, and most of the Antelope Valley is just alluvial fill, which would not be suitable for us. But we did site next to this former volcanic feature, given that the expectation that that would be suitable for us, and we're pleased to report positive results so far. So I hope that answers your question.